Good morning, class. Today we're going to begin our look at differential equations. Essentially, a differential equation is an equation that contains derivatives or differentials. If it contains only first derivatives, we call it a first-order differential equation. The method we're going to focus on is called separation of variables. Here's what the original equation may look like. You can see here we have the differential dx and the differential dy. And currently, anything can be attached to these differentials. We may have constants. We may have functions of either x or y, or we may have functions of both x and y attached to these differentials. What we need as our final equation is the following. Stuck to the differential x, we may not have y. So this function a at x does not contain y. And also stuck to the differential y will be the function b at y. The key is that it does not contain an x. Once we have this form, we will simply integrate with respect to x and integrate with respect to y, and we'll obtain our final result. Okay, let's get started with some examples. So here is the first example. Here we have the differential dy and the differential dx, and we're actually set up perfectly to integrate because stuck to dy right now, we do not have an x. And stuck to dx right now, we do not have a y. So we're all set up to integrate. So what's the integral of y squared? It'll just be 1/3 y cubed. Plus sign. What's the integral of x cubed? It's 1/4 x to the power of 4. And we'll certainly have a constant of integration here. Now, it's a nice thing to do, clearing out the fractions. So we can eliminate these fractions by multiplying all terms here by 12. So this would then be 4y cubed. And multiplying by 12 here will give me 3x to the power of 4. Now over here in the final answer, we would have 12 times this original constant. So what I'm going to do is I'm going to change the original constant to C1. And here then we would have 12 times C1. But we're just going to call that C. So we're going to make a little note here that our final C is 12 times the original constant. Okay? So we want the final answer to contain C. And that's why we make this a temporary constant until we've cleared out the fractions. Okay, let's take a look at number 2. Where are the differentials? Well, here is dy. dx is actually in a denominator, and that's never good. So we're going to start by multiplying both sides of the equation by dx. And so that's already an improvement because we don't have dx in the denominator. Okay, so differentials cannot be in the denominators. All right, now, are there any issues? Yes, because here we have the differential dx, but stuck to it is y. So this means that we should now be dividing these both sides of the equation by y, and that'll eliminate the y here. So if we divide the right side by y, it will look like this. And now certainly we also have to divide that left side by y. So it'll be 2 over y dy. Okay, so this is now fine for integration. Here, to integrate, we have to split this into 2 terms. So it's going to be x over x plus 1 over x. So remember, this can be done because there's just one term in the denominator. Okay, so that's when we're allowed to split this. And why is that helpful? Well, this now gives me 1 plus 1 over x dx. Okay, so in the right side, we're going to be integrating 1 with respect to x and also 1 over x with respect to x. Okay, so if you want to, you can write it like this. We're going to integrate 1 with respect to x, and we're also going to integrate 1 over x with respect to x. Okay? And now we're all set for integration. So the left side will have stayed the same the whole time, and now I'm ready to integrate both sides. So I'm just going to do this. Left side will have stayed the same. And now I'm ready to integrate. So what I need to do is integrate 2 over y with respect to y. And hopefully you remember that this will just be 2 times the ln of y. Okay, so now on the right side, we're going to integrate the number 1 with respect to x. What is the integral of the number 1? It is x. Oops. So we end up with x in that spot once 1 is integrated. Plus, and now what do we have here? The integral of 1 over x with respect to x. That's the ln of x. All right, and of course, we would have a constant of integration. Now, I want to show you that at the back of your textbook, so inside the back cover, there are formulas, okay? So all of the ones that are helpful for calculus, so derivatives as well as integrals. And here's the rule we've used twice in this question. The integral of du over u is ln u. And we had the integral of dx over x and also the integral of dy over y in this question. Okay, so let me show you once again. This one is 2 times the integral of dy over y. So that's why it's 2 ln y. And right here, we had the integral of dx over x, which is ln x. Okay, a nice thing to do in this kind of question is to combine your logarithms. So you might remember how to do this from your previous math course. If we're going to combine the logarithms, then first we have to take this coefficient and make it an exponent. So this is ln squared, right? And next I'll bring this term to the left side using subtraction. And now we have the subtraction of 2 logarithms. How does this combine into a quotient in the argument? And so that is a nicer, more compact form of this answer. Okay, so we end up with the ln of y squared over x is x plus c. Let's continue. We'll try this example now. Okay, so the first thing to do is correctly separate the variables. Well, we got a lot of problems here because the differential dy is here. We do have x stuck to it. So we have to divide both sides of the equation by this, the square root of 1 plus 4x squared. So we can do that first, perhaps. Okay, just like this. But now here's the differential dx, and unfortunately we have y cubed stuck to it. So we also have to divide both sides of the equation by y cubed. Okay, so in this step, I think I will also replace that square root with the fractional exponent of a half. Okay, this is always important for both differentiation and integration. So we now have the variables properly separated. So that's good news, right? There are no x's in here and there are no y's in here. Now we just want to get them ready for integration. To get this ready for integration requires us to write it like this. Use a negative exponent. Okay, same thing here. To get this ready for integration requires us to use a negative exponent. Now these are ready to be integrated. And this one is done very easily. Okay, it's just integrating y to the negative 3. So how is that done? Well, you add 1 to the exponent, so that'll give you negative 2. And in front of that, then we will have 1 over negative 2. So that is now properly integrated. Okay, it's just like when we integrated the number 1 here. Okay, the number 1 is x to the 0. So you add 1 to the exponent of 0 and you get x to the 1. And in front of that would be 1 over 1. So this right here is 1 over 1, x to the 1. And that's because this is x to the 0. Okay, so it's the exact same rule right there, the most basic integral rule. Now this one, in order to integrate it, it requires a u substitution. So if I'm going to do that, I'm going to do it at the bottom of my page. I don't want to do all that u substitution right here. So I'm going to go down here and do it, okay? So let's take the integral here, and I'll show you what I mean. Okay, so you have to take the inside of the bracket here and call that u. So u is 1 plus 4x squared. Great. So what then is du? Du is the derivative of that. So it is 8x dx. Okay, so now we come back over here and we're going to rewrite the integral. This, of course, is u to the negative half, so we're going to have that there. All right, u to the negative half, but we have x dx. So how does x dx compare with 8x dx? Well, it is 1/8 of it. So we have 1/8 of du here. Okay, so again, that's because x dx is 1/8 of du. It is 1/8 of 8x dx. Okay, and now we integrate u to the -1/2 by adding 1 to the exponent to get a half, and in front of that is 1/1/2. Okay, and then of course there'll be a plus c. So what does that give us? That is 1/8 times 2. So 2/8 or 1/4. So we get 1/4 u to the half. 1/4 of u to the half. So finally, 1/4 of 1 plus 4x squared to the half plus c. And so that's what goes here. What goes right here is 1/4 1 plus 4x squared to the half plus c. And so at this point in time, we do indeed have all of the integration complete. What remains to be done here? Well, it would be nice to clear out these fractions. Okay, so if I'm going to clear out these fractions, I'm going to multiply by 8 or by -8. So again, actually no, I guess I can multiply by 4. That would be even better, right? Multiply by 4 or -4. So if I'm going to do that, I'm going to temporarily change this to C1, and I'm going to choose -4. So I'm going to multiply these terms by -4. So that'll be positive 2 y to the -2 equals, so if I multiply here by -4, I'll get -1 plus 4x squared to the half, and then this is -4 times C1. Cleaning this up a little bit more, I can change this back to a positive exponent, so it's 2 over y squared, like that. And I can also change this back to radical form right here. Okay, and you know, I think I'll probably bring this to the left side just so I can make that positive, but that's just a little minor thing. So I'm gonna put that here. Okay, so my radical has been added to the left side, and this is where I would still have -4c1. But since this is now my final form, I change it to c. Okay, and I'll put a little note for you. My c is equal to -4 times the original constant. All right, and that is example 3. So again, once I got it to this point here and I was ready to integrate, the left side was very directly integrated, so I did it here. But this one here required a u substitution. So let me put a star. Because it was going to require a u substitution, I went down here and integrated it fully, finally got the answer and placed it here. All right, so you might want to always do that when you need a u substitution. Okay, let's go ahead and look at another example. There we go. So we're gonna try this one, okay? First step, get this differential out of the denominator. So first step is multiply both sides of the equation by dx. Secondly, take a look. This says dy, but I do have an x stuck in here, okay? But it doesn't seem like I can easily move just the x squared. So how do I handle that? The x squared has to get out of here. Well, I can common factor y here, look. So take y out. And now that y has been taken out, I can move this binomial, okay? So the binomial itself is going to move now. So we divide both sides by x squared plus 1. So we're going to have tangent inverse of x over x squared plus 1. Just like that. And now we're all set. If you have a good look at that, you can see no x is in here, no y is in here, so we're ready to integrate. Okay, this guy on the left is easy to integrate. This is y to the 1. So how do we integrate this? We make the exponent a 2. In front will be 1 over 2. Now, for this integral, I'm going to use a u substitution. So that means I'm going to do it at the bottom of the page. So here we go. I'm going to put a little star, and I'm going to come down here. So we're trying to integrate the tangent inverse of x over x squared plus 1, and with respect to x. So I need to properly assign a u. And there are really two choices. Either x squared plus 1 is u. But if I think about that for a minute, if x squared plus 1 is u, then du is 2x. Okay? This has no relationship to 2x. So that's not going to work. So this means that the correct thing to do is to call tangent inverse of x my u. So then the question is, what is du? Du needs to be the derivative of the tangent inverse of x. So let's take a look at that book jacket. We want the derivative of the tangent inverse of x. And in fact, it's here. So the derivative of the tangent inverse of x will be 1 over 1 plus x squared. And then this is just dx over dx, which is 1, okay? So we have 1 over 1 plus x squared. So du is 1 over 1 plus x squared dx. So now we come over here and we make our integral sign. This is u, okay? So we have u right here. We have u right here. And then, what else do we have? Well, u is multiplied by 1 over x squared plus 1 times dx. Here, let me first write it like this for you. It'll be easier. I want to make sure you understand, okay? So basically right now we have that, and it's multiplied by 1 over x squared plus 1 dx, okay? Certainly you should be able to see that this is the same as this, okay? So I can write it this way, and now it's easy to see that this part is simply u. And what about this part? Well, this part is exactly the same as this. So that means it is du. So we are simply integrating now u with respect to du. What's the integral of u? It's 1/2 u squared. And then, yes, plus c. So it's 1/2 of the tangent inverse of x, or the arctangent of x, all squared plus c. So that is what goes here. 1/2 of the tangent inverse of x, all squared plus c. Okay? Now I can cancel out the fractions here, so I'm going to make that c1, and I'm going to double the terms. So doubling this term and doubling this term means doubling this one. So this will be 2 times c1. Final answer. So c is twice c1. Okay, so that was a 4th example. And again, calling the numerator u worked in this case. And again, it's important for you to be able to see that this is the same as if we had tangent inverse of x multiplied by 1/x² plus 1. Because then this is exactly u and this is exactly du. Okay, one more. Let's do one more together. So the independent variable in this question is t instead of x. This is y prime. So the very first thing we have to do is change y prime to dy over, now normally dx, but in this case actually dt. Okay, so that was our first step. Change y prime into dy by dt. Next, we can't have the differential in the denominator, so we're going to multiply all terms by dt, and that'll look like this. Okay, so that is looking better now. Now take a look. Oh boy, in here we should not have y². So we have to divide all terms by y². So that took care of the problem in the first term. But look at the second term. We should not, in this term, have this binomial containing t. And again, that's because the differential is dy. So we need to divide both terms by e to the t plus 4. Uh-oh. Okay, and now we're finally in business. So we now have that final form that we were aiming for each time, right? So beside the differential dt, we do not have y. Beside or attached to the differential dy, we do not have a t. So this is in good form. Now we have to integrate. Okay. This one, in order to integrate it, we have to make it y to the -2. All right, and then that's not going to be a problem. We'll be able to integrate it right here. But this guy is going to require a u substitution. And so what does that mean? That means I am going to go down to the bottom of the page to integrate this term right here. Okay, So I'm gonna go right here and I'm gonna write it out. All right, so I'm gonna try a u substitution in this integral. So what I'm gonna do is call the bottom u. So u is e to the t plus 4. What is the derivative of that? Well, hopefully you remember. Anyway, hopefully you remember the derivative of e to the t is just e to the t. And it would be plus the derivative of 4, but the derivative of 4 is 0. So we have e to the t dt as our du. Okay, so this integral then, right, what does it become? Well, u is in the bottom. Okay, so we have u in the bottom. This is what we called u, and it is in the bottom. And what about this part now? E to the t times dt, that's exactly du. So we have the integral of du over u. And what's that? That's the ln of u. And again, we did use that, what was it, in the second example today. We've used that same integral twice, but I remind you it's right here, okay? So again, u is in the bottom. The derivative of e to the t plus 4 is e to the t dt, and that is basically the numerator, du. Okay, so we have the ln of u plus c, and that translates to the ln of e to the t plus 4 plus c. So that's what goes here. Back into our equation, we get the ln of e to the t plus 4. Okay, and yeah, plus a constant. The constant certainly has to be located somewhere, but normally we like to put that maybe on the other side of the equation, that constant. Okay, plus, now we still have to integrate this with respect to y. So this becomes -1. In front of it will be 1 over -1. And again, the constant more naturally falls here. All right, and so just to finish this up, this will now just be like a -1. So we'll have the ln of e to the t plus 4 minus, and you can leave it y to the -1 or change it to 1 over y, and then the constant would be here. All right, so in this video, we went through 5 examples. I will be posting a second video with several more examples for you as well. Okay, so please take the time to also watch the second video where I will do maybe some more advanced problems for you. Okay, thanks so much.